I got the report. All right. Couple of things first. I do have last week's recordings sitting there in Blackboard for you. So if you want them, both. I've got to collaborate from last week in both sections, lectures, out there. So all of that's there. I don't have yesterday's collaborate session yet from the online class. I didn't have time at all to think about that last night. And so we're on 6 this week. Next week we'll be on 7, and we'll have tests next week also. Because it goes 4 through 7, if I'm remembering right. 1 through 3 was first one, if I'm thinking right, and 4 through 7 is second. So that one will be available Monday, but I wouldn't recommend taking it Monday, since we won't have covered 7 at all. And so that'll be there. This week, there's actually not as much material in there. This chapter is a lot lighter. And then we go back to addressing next week. I don't know why they got these 2 chapters in the order they do. I would switch chapter 5 and 6 in order if I had to. I would do it last week's after this week, because this week's got nothing to do with number systems. Next week, the next couple of weeks will have to do with number systems. And so I would switch those around. So we're going to look at the data link layer today, and a couple of things off that one. I'll say there's not as much in this module for you. And so I do have that other stuff posted. Yesterday was just one of those long days. Today is actually on day 2, but partly it's school here, and I actually do have a full day at school here today. And then I have another thing to do tonight that I teach at another place. So that's my move. Yesterday, I actually had stuff related to classes. I was working all day from 8:15 yesterday morning till 10 o'clock last night. Because I had collaborate sessions all day for the online sections, and that are in the online courses I'm on. I think there's somebody in courses I went here, but I don't remember. And, well, we at least got one other. Okay, well, you're in 1220, aren't you? That's what I see. So you're in one of the online courses. And I'm not sure who's in what otherwise. Just happened to be when I went to look at discussions real quick this morning, the summaries out there to meet school requirements. I saw her name pop up there in 1220. And that's just where it goes. So I did meet their requirements where y'all are having discussion. They're having discussions every week in the online. Y'all are having discussion in class, so we don't have to do discussions. It's supposed to be more than just y'all are heads all the time. But they're assuming we're actually discussing stuff in class. And then I'm supposed to be summarizing and responding to discussions every week out there too. Well, the one due a week ago, I hadn't done. And I put a summary out there real quick this morning, which is all the school says I have to do. I still got to grade it and go through them all. I grabbed a few people's comments and called it a summary. I didn't want everybody to come up with it and made a comment or two myself. Went to do last week's, that was due last Monday, and in the hurry this morning, I went ahead and did what was due yesterday. So I'm actually technically caught up on those. Not realistically, because I still got to go through them, look at them. So yesterday I did those all day collaborates, and several of the sessions ran almost an hour, and I gave them 55 minutes because I got another session next hour. And at some point or another, when I'm doing 9, 10, 11, 1, and 2, I have to have one of them fall a little bit shorter because I do have to take a couple of minutes break at some point in their fit. And then I had a student that needed assistance in Rome to meet me yesterday afternoon, so I drove to Rome yesterday afternoon, went down there, met with the student. I showed about 4:45 when I met the student. And then left there about 6, came back up here, got back to my apartment after 7, and then at 8 o'clock I met with 2 of my interns. I've got this semester, 2 students that are taking internship. And they're redoing my web page and another web page that I do for an organization out there. And they needed input from me, and what was I willing to let them do on my page. And that ended up taking, we got going on, it was supposed to be at 8 o'clock, I had to get it installed on my machine, Skype and stuff. And they hit some glitch too, and so they pushed it to 8:30. But really, I was working from 8, I didn't get in the house till 7:30. And then I did look at some other stuff real quick. I graded something in some classes real quick right there, and then it was 10 o'clock and we got off long. So basically, I worked 14 hours yesterday. I don't know why I'm tired this morning. And I did not look at email last night, so if y'all sent me an email after about 2 o'clock yesterday, I haven't seen it. I did look at one this morning from one person I saw when I had to look at email real quick because I had some forms to turn in for the college. Because I had to take a training course that took about 30 minutes on handling hazardous materials. Yesterday, and I had to turn in a certificate from that one. It was not, and I have to do it every year, and this presentation they have is 5 years out of date. That keeps telling you all through it. The legislature, Georgia legislature, is going to change laws on this stuff in the 2014, upcoming 2014 session, and also in 2015 when they changed how they do all the labeling. And I'm going, this thing is out of date. But I had to do that anyway. It's a mandatory item. And we're at mid-year through the year, so I had an evaluation I had to turn in also, where I had been evaluated. And so there was more paperwork. So, data link layer. Not a whole lot on this layer, but it's got a couple of interesting pieces you need to know from it. One is, it is the only layer that's going to have sublayers. So remember that one on it. Because that is one thing I have seen. I haven't looked at y'all's test or anything, so I'm not sure what's on y'all's test. But I know from previous experience and from other courses and from certification exams, that's one of the big things that out of the data link layer that will appear on various tests is the 2 sublayers, because that's unique about this layer. Okay? It's got an LLC layer, sublayer, and it's got a MAC sublayer. And LLC, and both of those are actually abbreviations. So, but the MAC, you'll see people refer to MAC, and not very often people even, probably a large number of people out there don't even know it stands for something. Okay? So with the LLC is the higher one. Let me make sure I get now correct in my mind what MAC was. The LLC is logical link control. That's the higher of the 2 layers. What happens on the data link layer is the data link layer actually sort of splits, and that's where the sublayers come into. Physical layer, we're talking about working with devices, okay? That's when it put it out onto media, remember. So you're really working with physical stuff on that layer. It is the physical layer. Above the data link layer, everything above there, it's about how things are done out there, but it's software type issues, okay? So it's the protocols, how are they talking to each other, but we're not dealing with how are we actually putting it out there. It is how they're talking to each other is what it's doing, but it's not how we're actually working with the data across it. So everybody follow on that? So down there on the physical layer, you're really putting it out there. Above that, it's what are we going to, above the data link layer, it's how are we going to work with this stuff, okay? On the data link layer, the logical link layer actually works with the above layers. So it's a software-driven sublayer. The MAC layer, which is media access control, that layer is working with the physical, okay? And so you've got the difference in how they're working there. On the whole data link layer itself, switches will be devices that fall across the whole layer, okay? On the bottom half of it, on the Mac, you'll see your NICs, network interface cards, which now aren't such a cards that are built into your machine, maybe as part of the motherboard. That those will be associated there on the Mac layer, besides them being on the physical, okay? So you'll see NICs, and if you remember when I talked about the physical layer weeks ago, so I did tell you that when I mentioned NICs, so I said NICs would also be on the next layer. But everything else is just associated with one layer when we talk about devices.
And NICs are associated with all of them too? Is that what you're saying?
What?
I missed that part. You're saying NICs were associated with all of them as well, or?
NICs are going to be on the physical layer, and then they're going to be on the Mac sublayer. Okay? So you'll see them as being on the data link layer, but they're really working with just the Mac part. So everybody follow on that? So if you get asked about on the data link layer about a device, yeah, NIC's going to be for the layer because it is used in the layer somewhere, but it's really falling into the bottom half of the layer. So everybody follow on that part? So like if you look at my summary sheet that I gave you back in chapter 2 or 3, whenever it was, I guess that was module 3, when we talked about the layers of the two bubbles, that I've just got NICs there listed on layer 2, okay? I tell you there's 2 sub-layers on that sheet, but I didn't split any stuff apart. Now, so the logical link layer is going to be really concerned more software. The Mac layer is going to be concerned more with the hardware. And beyond that, you're really not going to, and then we're going to fool with MAC addresses. So on the Mac layer, your MAC addresses come into play on that way, okay? The MAC address is the address that is burned into any network attachable device, okay? So everything that can attach to a network is going to have a MAC address burned in it. So that means your phone has a MAC address on it because it can connect to the internet and networks, okay? Even if you got a flip phone, the newer flip phones all do that also, okay? Not only if you got a really, really old phone, which isn't going to work on our networks now anyway, so you got it there as a museum piece, not as a working piece. My new camera has got a MAC address on it. Because I can connect to Wi-Fi on the camera to upload pictures on it, okay? So there's a MAC address in there. All of your computers have got MAC addresses on it, okay? So anything that can connect, that has a connection to the network, has a MAC address. The MAC address is going to be 12 hexadecimal characters long. So yeah, we do have a tiny bit of play right here with number systems. And I guess that's where they went from, but that wouldn't be my thinking on it, but that's okay. But it's got 12 hexadecimal characters to a MAC address. Usually you'll see them grouped in pairs of 2 out there, okay? And with dashes between them, that they could be just 12 hexadecimal characters all jammed together. You will find the MAC address on your device somewhere. Sometimes it's usually very visible. Sometimes it's a little more hidden inside. Your phones tend to hide it, but if you pull your battery out, usually it's sitting behind the battery line. There's a little label there, it's got the MAC address. Okay? Other devices will see the MAC address real quickly. So if we look on here, MAC address is sitting right there on the back. So we can find it right off the bat there. In their case, they didn't put any dashes or anything in it, they just got 12 hexadecimal numbers together. Okay? So, now, with the MAC address, the first half of it is going to tell you who the manufacturer is. So manufacturers get issued the first half. Okay? The second half, the manufacturer will assign themselves. And remember the rule I said, everything's supposed to have a unique address in the world. Okay? So they have started reusing some numbers again now, also from some real old equipment that's absolutely, everybody agrees, isn't in use anymore out there. So they have started on that a little bit again. But basically, every network device has a totally unique MAC address. If you go to the SCC website and type in the MAC address of the device you've got, it will tell you who the manufacturer was, because they've got the code, the table of all the manufacturers. So when you can actually look up a MAC address and see who made that network interface. Now, that doesn't mean who made the whole box it's in, okay? Just who made the network interface that's there. So on your motherboard, who made the motherboard, okay? Or who made the NIC card, if it's still a separate card on it, whatever, okay? So there's an organization out there that issues out to the manufacturers their manufacturer code. When they run out of numbers that they've built so many devices, they go back and get another number, okay, and continue on building. The only MAC address that I can tell you a manufacturer address of, as far as I know, is not being used now, but I'm not sure if they're not. I've heard rumors that they are using it again now. As Cisco had originally, they were given the MAC address when they first started doing the whole thing, was they were given 000000C for the manufacturing part. C for Cisco. That's why I can remember that one. Okay? I'm not sure if I've ever even been told any others, but Cisco's actually mentioned it a few times when I've been in some trainings there, so they've thrown that one out as an example. But they ran out of numbers on that long ago, so they're using other numbers now. Okay? But I've heard that they've actually gone back and reusing that one again, so because that stuff was from back in the early 90s, and none of that stuff would be being used today on networks because of how slow it was designed. Okay? So I don't have to worry about on it, because you're not supposed to have two devices anywhere on a network that both have the same address. My system did goof up back in somewhere around 2000. One of their plants did and released a whole bunch of routers with the same address. But somehow their manufacturing plant didn't do the job right. And that MAC address is not changeable. It is burned in at manufacturing. So they follow on that? Now, having told you that, there's an exception to that rule. You can't go in and change the burned in address, okay? So we got that part. However, on routers, a lot of routers will allow you to go in and put a different MAC address in that it then presents itself as. And that's what's seen out there. Now, there's a reason for that, okay? Because the routers are your backbones of your networks and connecting to the internet, okay? So you've got stuff in your network that's built on working back to the router, using that router's MAC address as switches and routers talk to the routers that built some of that communications. They actually got written into the machine, written in the code. The MAC address is going to, as you put tables out there for it, okay? If you have a router fail, and you got to replace that router, by being able to put another router address in, you can make it look like the old router and not have to go around all your other equipment and change those settings. So everybody follow on that? So you're making it look like it's the other one, so you're still abiding by the rule that there's no two pieces of equipment out there with the same MAC address, because the MAC address you're putting in there, you know, is not in use anywhere else in the world, because that's that burned up piece of equipment sitting by you, or a completely defective piece of equipment that doesn't work anymore that had that burned in address. Okay? Does everybody follow on that? So that's one case you'll use on. Okay? And that's bigger organizations will do that sometimes. It's a whole lot quicker to get your whole stuff back up after that router failed. If you can just make everything else think that's the same router sitting there as sitting there before. Okay? Second one is your home routers, like this one, actually will let you do the same thing. Okay? And there's a reason to do it there. A lot of your internet providers, particularly the cable ones, how they determine whether or not you're subscribing to them and whether to let the traffic through is that they use the MAC address. Okay? And that when they install and go and set up your connection to the internet, that they take off the MAC address of whatever device you've got that hooks back to their box. Okay? Which may be that when they came and they set you up, you may have only had one computer there, and that they connected that. You got that computer hooked up and running, and used that MAC address to send to the office saying, here's the MAC address of this location. And so it's going to be allowed through as long as they pay the bill. Okay? And so they've got a table sitting there in their company that's got all the MAC addresses for all their subscribers. Okay? And that's how they keep up with it, and that's what decides when you connect to the line there, does your stuff go anywhere, or does it just get to their router in their office and die right there because it's recognized as not acceptable traffic. Okay? So everybody follow that? So if that happens, and you go and you then get your switch, your wireless access point, and you hook it up to it, and you hook your computer that you had up to it, and you hook something else up to it, maybe your phone or whatever, that you're now connected in. All of a sudden, you discover it doesn't work anymore. Unless you got just that original device plugged in. So if you try to put the other device in, all of a sudden it don't work on anything and things go crazy. Problem is, it's only looking at that old machine that you had on its MAC address, and when it comes through, it says, okay, that's fine, I can work with that. The other one you've plugged in, and then you flipped into that box that's hooked into the other box, looks at it and it looks at that coming out and says, that's not a MAC address I recognize, I'm blocking that traffic. What you can do is turn that box in, and actually most of them, and that one does specifically, it will allow you to go in there, have just that original device hooked up to it, and there's actually a setting in there that says you click on it and tell it, emulate the MAC address of the device that's connected. So then this box takes the address of that other box, or you can actually type it in, okay? But remember, it's 12 hexadecimal characters, and for the normal person, they have no idea in the world what it is, but when it says you can emulate the other machine that you have, that people can understand something on it and go, okay, I can do that, and try that and see what happens. It then takes the MAC address onto this box, and so that everything that connects to that box when it sends it out, when it leaves that box, it's got that MAC address on the frame. Okay? Now that means everything is recognizable. Now, with today, where the box that they're getting you from your provider is actually more than just a router sitting there on it, that actually has all your connections sitting there on it and everything, they're going off that box and everything's passing through that box, so you really don't have to do that unless you've got an older box still sitting there. But if you've gotten a new box from your provider, it's working off that one anyway, because think about it, most of them have now got wireless sitting on those. They've got 4 or so plugs where you plug devices back into it, and so on. So it's sitting there doing that switching capability too, and it's really routing from there, okay? And it's not pulling from the original device anymore. So that part is going to disappear. The second one, you're not going to see much use of it anymore, but that was important for a good while. And that it would goof up people up. Because your other part was, you had to call your provider when you bought that box, and like, I'm going to start using that box to connect all my devices to. And get the one line back into the one line spot of the other, that you had to call them and tell them what the MAC address was for there. They had to change it in their table, and everything was working also. Or you could just make that box look like it was the address they had anyway in their table, and everything was working. So you can fake it around on it sometimes, but in any event, in both examples I've given you, the MAC address on both of those routers, a commercial one that we talked about first, with a smaller one, still stays exactly the same. What's thrown in there, we're just having it stick a different MAC address on all its frames it sends out. Okay? So everybody follow on that? But the big part usually is, the question for you on a test is, can MAC addresses be changed? No. You can have another address fake for it, but you can't change burned in address. Okay, so everybody follow on that? So with the MAC address, we're going to use it on frames, and so now we're going to start talking about our different data units. That you're going to have, and so we're going to have frames on this layer. And with the frame, you're addressing it down to the device. Okay? So you're going to take your packet that's from above that we'll talk about next week. Okay? You're going to package it in there, you're going to encapsulate it in there. And then you're going to add on there the MAC address of the device it's coming from, and the MAC address of the next device it's going to. When we get to the next layer and we talk about IP addresses, that's going to tell you where did it originally start from and where is it ultimately going to. But MAC addresses are just going to tell you device to device. Does everybody follow on that? So which device did it just come from? Which device is it going to? Okay? And back to my post office example I gave you back when we talked about the layers. At this point, we're talking about when they drop it in the bin, they're in the post office. And when it gets to the distribution center, where it gets dropped in the next bin. Okay? And gets rolled out and put on the plane or on the truck. At that point, and then that bin just says, here's the next distribution center or post office it goes to, but doesn't tell us anything about where is it ultimately going to, just where we're getting to the next one. In your car, it's either where you're going to that you're going to stop at next, or the gas station you got to stop at next along the way. Okay? It's not looking to the end, unless you've gotten to the last stop location before you go to the end. So the MAC address is going to just tell us which device did it just come from, which one sent it. That's the source MAC address. And which address are we going to next? Which MAC address does it go to next? Okay? And that's going to be the destination MAC address. So that's going to go on the frame. There's a couple of other little pieces on it that's going to go on that frame. There's going to be a start delimiter on the frame that says, here's the frame, and a stop delimiter on the frame. Think about it as older trains on that one. There's an engine on the front of it and a caboose on the back of it. Or in today's trains, there's a red flashing light on the back of the train. Okay? That red flashing light and the engine is the start and the stop spot. Because you got all that traffic going across the internet, remember? So something's got to tell us, all right, here starts the frame, here stops the frame. So it's got a delimiter on each end that marks the beginning and end of that frame that's coming through.
So the beginning and end frame carry the destination that comes from the destination it's going to, and in between that is whatever it is.
So it's going to have a start delimiter, and then it's going to have the two addresses. Which, oddly enough, the source one comes first, the destination comes second, which always confuses me because I want the destination first on it. When we look at the IP addresses, they'll be the other way around. They'll be logical on that. But it's going to have those two addresses right there. And the big part you need to know what that is, there's start delimiter, then there's the two addresses. There's a source and a destination. I think I've only seen one time anything about a question that was, what were those two addresses were on? It's just, what is the major things inside the frame, okay? Then after the addresses, maybe a little bit of information right there that it adds on there, but the book doesn't even go into that part right there for you. And then there's the packet, which is packaged inside that packet is your actual data you're trying to send. We've still got some more stuff to add to it and go layers. Okay? But it's actually got the data inside the packet. So there's the packet. So it's encapsulated in there. So everybody follow on that? It's just like medicine. If you go get a capsule of medicine, you know, all y'all have taken capsules of medicine at some point. There's a wrapper around the actual medicine inside all its little pieces, right? So you've encapsulated your medicine. Okay? In the same case here, we've taken the packet and encapsulated it inside the frame. We've got other stuff wrapping around it on the frame. So you'll see that term all over the place out there, that we've encapsulated the packet inside the frame. And then after the packet, there's a few more pieces there. There is a code there that does a measurement to make sure that all of it gets there. which they've got listed for you on down there where they talk about the frame. So it's a header, the data, and the trailer. But the header, like I say, has got the frame start, the addressing. Actually has the type of frame and the control. But those two you really don't have to worry too much about on the type, but it's just what type of frame this is coming through. And the control is just information it needs to control on. And you really don't get into that stuff. Okay? And then the data. And then you got a trailer. So you've got a header that has that front stuff. The big part on the header is it's got a start part to it, a start marker, and then it's got this address, the MAC addresses. The data is your packet that's encapsulated in there. And that's what you're really trying to get across there. And then you got a trailer. And so do know that you got a header and a trailer around the data. And so then they mentioned that you've got two pieces on the trailer. That's what they showed to you, is that you've got an error detection on the trailer. And what that is, it depends on which type frame you're sending, etc. on it, but it's just where it's done a calculation on the value of that frame and sticks a number in there. And then when it arrives, it does the same calculation, compares the number when it calculates when it arrived to that number that's inside the frame. If they match, our assumption is it all arrived. Okay? If it doesn't match, something's happened to it. It got damaged or something that didn't all get there. So they follow on that. And it doesn't have to, and so they've got all these kinds of algorithms out there. Don't ask me what's in the algorithms, I've never seen the algorithms. That's all done internally in the machine. It's not something we have any control. Okay? For one thing, you don't want control over it because both ends are going to have to agree on it. So that's where your protocol comes into play. Okay? They got to be both talking the same way. They both got to do the same calculation to get the same number. And then the last piece on that is that then it's got a stop value that sits on the back end that tells it this is it. And so there's a frame stop delimiter on the back. So there's the delimiter on the front and back that says start and stop of the frame. There's some other information in the header, the address being the primary part. Control is there too, that has some other, passes along some rules between the two machines that the protocols can look at and go, okay, I know something else about this frame on it then. And then the type tells it what type of frame it's come across. There's several types of those, but again, on frames, you're not really worried about that. When we look at packets, well, actually, we look at some types on that one. So you're going to have some of the same stuff next week, not next week, following. Yeah, next week. When we look at packets, you're going to see a lot of the same type of stuff falls inside what's being encapsulated there. Okay? I don't know what they're doing next door. And that's just offices over there.
So it was a class or something.
No, it's offices next door.
That is a loud thing.
And they make comments about noise in a couple of our classrooms. That's why I stepped out when we first started and they were making noise to make sure it's coming from where I thought it was. Nobody over there. Because that is a classroom sitting on that side.
Great.
So has everybody got the idea of what a frame is now? So at this point, it's a lot of stuff y'all are really looking at, are going to be looking at and are interested in, is all in that encapsulated area. So we're really not looking at the real data or anything else. It's all filtered down to us. Okay? And if we work from the top down, you'd be sitting there the same. just with a similar type thinking of, wait a minute, we're wanting to get it on the wire, I want to go back and get it on the wire, and this other stuff we'll deal with this later on. In this case, we started from the bottom up, and so we put it on the wire, and now you're figuring out what all's in there to put on the wire. So either way we try to teach it, people go, ooh, that's not exactly what I want done. But we'll cover it all for the end of the semester. Okay? And then we're working from the bottom up. So that's with the frame. And the biggest thing on the frame is that it's using MAC addresses, okay? Which is going to be put into that part on it by the MAC software. The LLC is going to put a lot of those other little things we saw on there into it, so control bits and stuff. LLC would be more concerned with that. But again, this layer we don't get very deep drilling into for a course like this. Now, if you were one that was developing protocols or working with developing the actual devices, you get a little bit more in depth. That's not what these classes are training you for, okay? But if you want to know all of that stuff in detail, then that's where you're wanting to get your computer science at the 4-year and master level doctorate level stuff. So that's really beyond the things I've ever done, okay? Now, so that's the big one on that one. They do talk about there is a little bit of difference on frames on a LAN versus a WAN. That's an LAN versus a WAN. So your frame does have a little bit of difference on it when it goes out onto the WAN, but it's essentially the same frame. So they do a little tiny bit of discussion about that, but it's really the same thing. It's all back to the basic same thing. So when you're sending it within the network, it's essentially the same frame that goes out there. And that you're just, it's not going across, going out. And so they give you some illustrations on that one. They mentioned about the IP address sitting in there in the packet, but we haven't touched that yet. We haven't gotten to that layer or talked about that. So don't worry about those yet. But when you're dealing with the WAN versus the LAN, what protocols it's using is going to be a little bit different. Because when you're working within the LAN, you're typically working with Ethernet. Okay? When it goes outside the LAN, and it's going from LAN to LAN, of course, the WAN, that then you get into some other protocols. At this point in time, you're really not concerned with those protocols. If you go on to the additional courses, to the second and third Cisco courses, particularly the third Cisco course is going to get into the WAN protocols, which is where we're going to get to PPP that you mentioned to point to point. And that one's used a lot out there. And that's used between them a lot. But then you'll get into, as you're going between LANs and going across the internet, you'll get in some others like frame relay, the HDLC, ATM, and they mentioned X25. But point to point is going to be one you'll see later. If you get to the third course, and I'm saying on the if, because some of you are in here, and I'm not sure in this class, but the others, the big class will watch this video some too. Some of y'all are taking the class purely to meet the introduction to networking requirement, as your computer support student. But if you're a networking student going to go into Cisco, you're going to take the other two courses. But if you're a networking student and you're going to be the Windows track, the Microsoft track, this may be the only Cisco course you take. And if you're in cybersecurity, if you do what Mr. Spurlock and I tell you to do, you're going to take all three Cisco courses. So between all of you, you've all got different points where you're aiming at on Cisco of what you're going to learn. And so I'm trying to, in this course, I have to keep that one in mind. Some of you aren't going to go on to bigger things in Cisco. Okay? So you may, in this course, we're not going to go into those WAN protocols. Does everybody follow on that? If you get to the third course, you're going to be setting those up. You're going to set those up on your routers. Okay? And set that communication up. Get those protocols working. So that's just more of right there. That's just terms thrown to you on it. But as they comment there, even out there on the WAN, a lot of it is using the Ethernet protocols anyway, even doing WAN now, not just the LAN. Because everything out there on LANs is now Ethernet. And whether you're wireless or wired, you're using Ethernet. Okay? If we go back 20 years ago and further, it's a whole different picture. Your LANs were operating off a number of different protocols, because you had token ring networks. I'll talk about in just a second. That you had other manufacturers. You had Novell with their network that worked off its own stuff, and that there was a bunch of different ones they worked off of. But they'd gotten compatible off the models, so they could actually talk to each other, even though there were different ones. But that meant in the LAN that you were using different protocols. Now, everything out there as far as the LANs is concerned has standard into Ethernet and using the TCP/IP protocols. Okay? It's very rare you're going to find something not using Ethernet and TCP/IP protocols inside the LAN. It's not to say it's not out there. If any of you decide to sign up for secret missions and go get on with NSA or CIA, you may be using some stuff, other things. But then you can't come and tell me about what it is you're doing anyway. Okay? You can't tell anyone else either. In fact, some of those jobs with those organizations, you're really not even allowed to talk with other people in any way. There's actually jobs that they will hire students out for to work on those that you're not allowed hardly to communicate even with family. That they put you in Washington and you can't have any personal communication devices with them. Some people, that's nice. Other people, that would never work. If you're a social preacher, it's not going to work for you. If you're one that's just purely by yourself and doesn't want around other people, that may well be a perfect job for you. Okay? So that varies on that one. So for me, that really wouldn't work for me to do one of those jobs. It would be interesting to go observe those people, but I couldn't do it. So that's going to be your big one off that. So they tell you on that. All right. Wait a minute, I just jumped chapters. Sorry about that. No, there's another item down here. Where is it? Okay, that's 6.3. Oh, okay, I skipped one. Okay. I was going to say, there's another little piece here. So I really want to go on into this today, or what y'all go early today. Because this won't take a whole lot and we'll be finished with the chapter. Let's do topologies Thursday. Okay? And it won't take a full hour and a half either. Okay? But then we can just talk on them. I'll go on the board actually a little bit with topologies. We're going to talk about physical topologies and logical topologies. So I've really done the first part of the chapter today and the last part of the chapter. We've got 3 parts to it, and we've done 1 and 3. Let's get 2. So we're going to follow on that part. Any questions on what all we talked about? And the other part is waiting on topology. So Thursday, that cuts down the amount of overload I'll put into your brain for that.
I do have one question.
Hmm?
When are we going to start doing hands-on stuff in this class?
Somewhere, actually, my envisioning of it, usually we aim for about mid-semester is where I do it. Actually, where it falls into us doing it should be in probably, it's probably chapter 8. So somewhere there in the 7-8 range. Somewhere along there, and it's wherever I see all time on it now that will work on that. The biggest part is we just need to do it somewhere before a couple of weeks before the end of the semester, and I'll do it again in the last week or 2 of the semester. So it really doesn't make any difference where we do that part in, and that will count as one of your labs. Make sure you are doing the labs on it. The labs should be falling for you related to what you're reading in the chapter, or you're actually doing some of this stuff. Last chapter, you didn't have any labs in there because it was doing numbers and it really wasn't doing anything onto equipment we were talking about. Students taught it all. So do make sure you're keeping up on those. I haven't graded y'all's first lab yet, but hopefully I can get that tomorrow. I did the online class on Saturday. I didn't get the 2 hybrid classes done, but there's 43, 45, something, I'm not sure. 40-some students in the online, okay? That took me scattered over the afternoon. I think I worked like 5 hours in grading their first lab. But that was also answering emails from students in the mix of it, and they have mixed in something else that I worked on, I think of a church service together. In the middle of that too, for a little bit of break. Just keep looking at the same thing for hours on end. You got to break away or you will start racing. Okay? And no telling what scores you'll get on labs then. There were a number of students that I found in there that had not been putting their names on their desktop. And I will do the same for y'all as I did for them on that one, is that if you don't have the name on the desktop, you're going to get back with a score of 0 on it. It tells you your name's not on the desktop, and to fix and resubmit, not for, fix and resubmit it, and then I'll give you the real score. On future labs, and I know you've done a couple of them in between since then, so I'll cover that. Future ones, there'll be a substantial penalty if you don't have your name on the desktop. So I got that. However, if you don't have it on the first one, on that module 2 lab, okay? I'm going to return that one to you and tell you you got to fix it. And if you're not sure how to do it, the video I put out there in module 2 that I made on King's holiday, I show you how to do that. Okay? If I had a chance, I'd do just a video just on putting your name on desktop. I can do that when it's not long enough to do a 5-minute video on that. And that was only a 37-minute video, and you jump around there. But I will give you all but I will also give you at that point, I will tell you I'm not going to grade the next ones for a couple of days. So like theirs, I graded on Saturday. I told them they had through yesterday for sure until when I went to grading again. But I was for sure knew I was going to until at the earliest today. I'm really not going to do it today. for them to fix their other labs and put their name on them that they did not have on desktop. So if you realize right now, you know how to do it now, and you're going, I know I didn't do it back on whichever one, you can go back and resubmit those. Okay, so we follow on that? And it's not going to be a late penalty if you're resubmitting where you submitted on time. So we follow on that part. So what I do have out there about the late penalties on SOLAS and stuff. If you submit it first one on time, and then you've got some little correction made to it correctly, and you submit it again before I grade it, I'm going off that original submittal. Okay? So everybody got that part? Now, if you haven't turned it in yet, yeah, you got a late penalty coming. Okay? But if you did turn it in, and there was a few other things that there was some things that if it's something major that I did do the same thing on and will do sometimes on the other, but typically it is going to get graded on whatever you have on. Okay? And remember, they do self-score. The very first one you did not do any scoring. So guess what? If you turn that one in and you put the console cable on it, which you were supposed to do, and then they had some different little things for you to just try out and try, but it didn't score you on any of them. Assuming the console cable is there, and you submitted it with your name on it, you got $100. If the console cable is not there, that tells me you didn't do what you're supposed to do in the lab. You just turned in blank lab with your name on it. Yeah, you can take a penalty on that. Okay? So the console cable's got to be there. It's the only way you can get it to work. And then there was a few people I've had, and I say I have not looked at y'all's labs, so y'all may have all done it perfectly. Okay? I may be preaching to the choir right now. Okay? But there were a few that instead of using the PK8 file that's out there in their curriculum that you're supposed to use, they went and tried to build their own file for it and turned that in. It comes in as a PK2 file and does not score itself. And I can tell right off the bat that that's that. And y'all can move the stuff around on the desktop. There's no problem with that. If you're going, I don't like where they got the couple of devices, y'all can actually move them around inside the PKA. That's not a problem. But you definitely need to use PKA files. And the ones that turned it in, that went and did a PKT. And don't save it as a PKZ, which is a zipped packet tracer one. That complicates it because then I have to tell it to unzip it and then open it up. Just like y'all don't want to give me extra work to do. Okay? If you haven't figured out the schedule's really full. So I don't want any more work that I have to do. Okay? So do just do the same, or you do save as. Don't do save as, like you do a save as PKZ. You don't need to do that. That's there. It's how you were turning them in or whatever, or we work with them. You need a smaller file. PK8 files are small enough that they will work fine in Blackboard. You can actually email them to me, so when you have a problem on them, this will go right on through the third semester. That they're still small enough files that y'all can actually attach them to your email and email them to us. Sometimes we all hit some problems. That's what I'm going to do. They write and ask me, tell me something doesn't work in there for you. I may well write it back and go, send me your PKA file. Because guess what? When you send me your PKA file, I can look there and see exactly what you did. And you've told me what step you were on. And if you don't tell me that when you write and tell me you're having a problem, that's going to be my first question. What step are you on? Because I got to know, what is it you're trying to do? But even if you sit there and you write and tell me, I'm trying to do such and such. Well, really, I need to know which step so I know what it is you're really actually trying to do. That you're telling me what you were doing to do whatever. It's nice, and I need to know. But I need to know what it is that you were trying to do. Because where you may have gone off on a wrong direction on it. That you may have misunderstood the instruction. So, one, if you don't tell me what step you're on, I'm going to write and ask you that. And two, when I look at or read what you said. Sometimes I can go ahead and answer it for you, okay? But sometimes if I could be able to go in and look in the PKA file and see what you have done, it may be a previous step you did wrong and just didn't realize it, and then I can look and go, oh, wait a minute, this is the command you need to fix, this is what you need to fix on. Right back and tell you, and guess what? I've done it myself right then in your PKA file at that point, so I know it works, which is really nice. I wish we could do that in the Microsoft classes, but those files are way too big, so you can't do that. It would be nice if we had, there is a hardware software solution out there. Only problem is it costs about $30,000 where y'all we could set up servers in here and y'all could actually log in from wherever into there and do your work on there, and it's all sitting there, and then iPad will go into it and see what you've actually done, and that we could actually both go into it together, you from home and me from school or home, go into what you're doing, see what you're doing, and work out. But again, I say it costs somewhere $30,000 to $100,000 depending on how much of the stuff we got in everything. They don't give you that budget here. Now, if one of you wins the lottery, if you'll come and give me that much money where I can buy it for the other students to be able to use and enjoy in the future, that would be nice. But then what would really be nice if you win the whole big lottery is just take us all on a vacation trip down to the Bahamas before you disappear. Okay? Because probably you're going to drop out of school, not necessarily. You may decide you want to keep on the classes that they're interested in. But you're not needing them to get work on. And then again, one of you may be sitting out there that has won the lottery. I don't know. Okay, any questions? If not, all of you that have already packed up your books and everything can jump up and make a run for the door out of your pack. But y'all probably not be down trying to get to the door.